Okay, a very good morning to everyone. Everyone meaning you only, madam. Very good morning to you. See, in today's class, we'll be discussing about screw gauge. Vernier caliper, you already are aware. Okay, more or less you are aware. You can handle that, I suppose. We'll send the video of vernier later. Okay, so this is, as you can see in the screen, this is nothing but a screw gauge, right? So over here, this is called as the dead end or the anvil over here. This is the one that can move over here. This is called the spindle, right? This can move this way, this can move this way, right? And this one over here is nothing but the sleeve, and this scale is also known as the linear scale. Okay, linear scale, you may also call it as the main scale. Okay, and this one over here that you notice, right? This is also known as what? This is known as the circular scale, right? Circular scale. Right. You can see some divisions which are made on the circular scale as well as on the linear scale. Right. So with the help of these divisions, we will be finding out what is the total reading over here. Okay. So therefore, now let us move ahead. Now, have you ever opened a jam bottle, ma'am? Yeah. How do you rotate the lid? As seen from above, you will rotate the lid in the anti-clockwise direction to open the cap, right? So imagine that this is nothing but the cap over here, right? This one. So therefore, how will you open this one? This is the circular scale over here, or the thimble, right? That you will be rotating. So you will rotate it in this way, right? In this way you will rotate it, so that you imagine horizontally you have put the jam bottle, rotate it over here, and this particular spindle will start to move in this direction, right? So therefore, over here you can imagine how the situation is, right? Earlier the anvil is in contact with the lead screw, right? So now as you start to rotate it in this way, the jam bottle is rotated, and therefore this particular screw will start to open over here, right? So as it starts to open, there will be a gap that will be created over here, right? So within this gap, you can put some objects. Maybe you want to measure the diameter of the chalk piece. So you'll put that over here, right? Now, as the screw opens, the you will notice that some divisions will start becoming visible. So therefore, over here, in this way, the divisions will be visible on the linear scale, and on the line over here which is coinciding uh, with the linear scale. On these also some divisions will come over here, right? Maybe this is the 33rd division, and two divisions on the linear scale are visible, right? 33rd division of the circular scale are visible, right? So as you can see over here, right? In this case, we notice that on the linear scale, suppose that each of these uh, divisions is of 1 mm, let us say, right? And therefore, this particular division is half of that. You can see where that smaller one is located, right? It's at the midpoint. So, how many divisions are completed over here? This is 5 mm plus half mm is completed, right? So, 5 plus half mm is 5.5 mm. That is completed, right? And on the circular scale, what line is coinciding with this reference line. You can see this line, right? Which division is that? That's the 12th division, correct? So we read it by saying that this is nothing but the linear scale reading is this 5.5 mm, and the circular scale reading is nothing but 12 divisions of the circular scale, right? So now how do you find out the value of this circular scale division? See, linear scale is fine. It's directly 5.5. What about the circular scale, right? So for that we are going to introduce a quantity called as pitch, right? The pitch is what you have studied in your magnetic effects. Also, this is nothing but the linear. This is not your cricket ground pitch, right? This is the linear distance which is moved for a a complete a complete rotation of whom of the circular scale, right? So who's going to move the linear distance? The spindle over here, this one. So it's just like the jam bottle. It means that your circular motion is being converted into a translatory motion. That's the principle behind the screw gauge, right? So, for example, let's say that uh, how many divisions are there in the circular scale? Let's say that this is the 100th division, this is the sorry, this is the 0th division, this is the and so on, this is the 5th division and so on, right? It goes, comes back. Over here, let us say that is the 95th one, 96, 7, 8, 9, 10, right? So totally, if you were to add the number of divisions, for example, let us say that there are 100 circular scale divisions. How many? 100, right? So if you rotate the circular scale by 100 circular scale division, it means you are rotating the circular scale once by one full rotation, correct? Because in one rotation there are 100 circular scale divisions, right? Just like in this one there are, you can see, right? In which way you will rotate it? To open this up, you will rotate it in that way, just like you open the jam bottle. Okay. Now, on rotating that, this this particular spindle, it will move over here by some distance, right? Whatever is the distance that this one will move is nothing but called as the pitch itself, right? The distance, linear distance moved for a complete rotation of CST. Okay. So now, if for 100 divisions, suppose that the distance moved is nothing but 1 mm, say, for example, let's say, okay. But what if you don't rotate it by 100 divisions? What if you just rotate it by one circular scale division? Then how much movement will occur over here? Definitely not 1 mm, right? That means this 1 mm is being divided into how many parts? 100 parts. And if you move by one CSD, you are just going to move by one part over here, right? So circular scale motion giving rise to translatory motion. Now, since this is the smallest distance that is moved by this by the screw over here, this is the smallest distance that you can measure also, because you can put some object over here, right? In this space, you can actually put some object and measure this particular distance, right? So we will call this distance as the least count. What is the least count? 1 mm divided by 100, right? Because 1 mm divided into 100 parts. So it's in general, we'll say that the least count, what is that? Is simply the pitch divided by total number of circular scale divisions, right? This is the pitch, right? Okay. So now if this is the pitch, then what is the reading then? Right. This is the pitch. So this is the total CSD and this is the least count. Then what is the reading? right? See, the reading will simply be a sum of two quantities, right? The reading which is shown on the main scale plus the reading which is shown on the circular scale, right? So if for one division the distance moved is how much was that? 1 mm by 100. If suppose you move this by 10 divisions, right? Then how much will be the distance moved? Can we say 10 multiplied by the least count? Yes. When the marking over here is 12, then how much is the distance moved? On the just after the 5.5 mm mark. After the 5.5 mm mark, you are moving additionally by 12. Okay. So 12 into the least count will be the circular scale reading. Main scale reading is simply 5.5 mm. Right. So here you just, so main scale reading, you don't have to do anything. You just look at this main scale and you put that particular reading over here. Circular scale reading is nothing but whichever division is coinciding, let's call that as n, multiplied by the least count. All right. That's the whole idea.